Hello, I am a student in my second year of electrical and electronic engineering degree, and one of the 6 modules we're studying this year is microprocessors. We've been asked as part of the module to design a car park entry system as to monitor entrance and exits to the car park, as well as tracking the amount of vehicles or spaces available in the car park. There's 52 spaces, and this all needs to be access and egress needs to be controlled with a keypad. So I'm just going to show you. I'm not going to run through the code yet because I just want to see the level of interest first. But I'll run you through some video demonstrations of the program at work and wait for the comments. So thank you. This is a demonstration of the 3D build for the car park system. You can see we've got 2 gates here. We've got the gate from this side with an LCD display, a keypad, an LED indicator, an entrance sign, and also on this side we've got this barrier beam here. We've got the orange barrier there with the white articulated, this barrier holder with a white articulated barrier that goes up and down. Hidden are the limit switches for the lower and the higher end, as well as the motor inside the orange cube there. These two shapes here are just for aesthetics. There's no functional purpose there. So if I just quickly show you the other side, you can see same setup. So when you start the program, we have an indication telling us there are 6 spaces remaining. On the exit display, there is no indication. They don't need to know how many spaces are remaining. So what will happen is I will trip the ingoing beam on the entrance side. That means a vehicle is approached. We'll get a welcome display on here, and then it will quickly go straight to asking for an access code. And I'll show you what happens on the opposite side as well. So trip that there, we get welcome, we have an access code request. If I switch to the opposite side on the exit barrier, what happens is this exit barrier freezes, stating the entering vehicle has priority, and a red light is indicated. This stays there until the vehicle has fully passed through into the car park from the entrance side. We have vice versa operation as well for the a vehicle approaching the exit beam first would lock out the entrance side. So returning to the entrance side, we have our access code request here. We've got some different functions. So if we start typing and we don't like what we've typed, which is shown as stars as well for security, we can hit star and it deletes everything. If we input the incorrect access code and press enter, we get a red light and a message telling us the code is incorrect. We'll input the correct access code, which is 1, 2, 3, 4. The barrier will start to raise. Sorry, we'll get a message first stating it's the correct code. There'll be also a message stating you may proceed when the green light is lit. So as the barrier raises, there is no green light lit. Once the barrier reaches the top, the green light will come on and the vehicle can pass under. This is to stop vehicles entering the car park whilst the barrier is moving. So let's press enter. Thank you. You may proceed when the green light turns on. The barrier starts to move. When the barrier reaches the upper limit, which is fully vertical, the green light will come on and the message will change. You can see that from a distance. So there we go. We'll zoom in. Please enter. Have a nice day. So what would happen now in real life? The vehicle already has this beam triggered, so broken. It will proceed forward and break this beam. So I'll simulate that by clicking the beam. And then as it passes fully under the barrier, it will clear this initial beam. So we'll cycle that and we get a new message saying please wait, the barrier is closing, and a red light to sort of enforce that. And what this is doing, it's allowing the vehicle to fully clear the barrier with no vehicles following it, the barrier will come down. Once the barrier has come down, it will hit the lower limit switch, which will then clear this message and reset everything back to normal. So it's cleared this beam. We're now going to cycle the final outer beam, assuming or simulating the vehicle has fully entered the car park. So we'll do that. We have to zoom in a little, unfortunately. So there you go, we've cycled that beam. We'll watch the barrier close. When the barrier fully closes, we should get an updated message here. There'll no longer be 6 places remaining as the vehicle has entered the car park. There should be 5. Lovely. So the LEDs are cleared, the opposite side is cleared, car park has 5 spaces remaining. Thank you very much. Hello, so this is the 2D portion of the assignment, the build that I've done for my second year university module. What I've done is I've brought everything from that 3D space and bundled it all together so we can see it in a 2D environment. And what we've also got here, you might notice if you've already watched the 3D video, is the additional button we've got here. This is an emergency start button for the barrier, a nice safety feature, and it's we've added it as an interrupt. So we'll run through the simulation now and check that it's all working as it was in the 3D space. So we'll have a vehicle. We'll run the program first. So F5. There we go. It's running. We've got 4 parking spaces remaining on the entrance display, and on the exit display there's nothing there. This time we'll go for the exit and we'll make this up to 5 spaces because we're going to have a vehicle leaving the car park. So as you might remember from the first video, a vehicle will approach the exit beam and brake it. That immediately tells the vehicle, any vehicles approaching the entrance side, that the vehicle exiting has priority and please leave room. Giveaway would have been a better phrase here, but never mind. I've finished it now, it's submitted, so this is just me running you through it. So on the exit side, we've got a request for an access code. The access code is 1234 on my program. We've also got an additional function of the delete a possibility of deleting what your input is. So if you put, oh no, I've put the wrong number in, you can punch star, and it'll delete it and reset it to the beginning. If we punch the wrong number in, so 1, 2, 3, 3, and we press enter, which is here, hash again, we get a code incorrect displayed, and we get this nice big red light to sort of reinforce the message. So we'll pop the right code in this time, 3, 4. Another feature, by the way, is this your code's displayed as stars, so people can't see what you type it. Well, they can watch your fingers if you like, but they can't see it on the display. So I thought that was a good feature there. We're going to press enter. The barrier is going to lift and clear this lower limit switch here. So we'll zoom out. The barrier is lifting. It's going to lift. It's a bit clunky because I've slowed it down a bit, but it does run smooth. Make that switch and that'll stop this hidden stepper motor I've got in here from moving. So we'll wait for that. Yeah, I wish I'd not done that now, but anyway. So that's going to make that switch, clunk, stops the barrier moving, and we've got a change in message, please exit, have a nice day, and a nice green light on. Okay, so the next thing that will happen is a vehicle will pass under from the exit side to the outside and break this beam, and as it continues it will clear this beam. So the only way for me to simulate on this is to cycle it again, so I'll click it. But in real life it would have been broken all this time and then become unbroken as the vehicle clears the beam. But probably my limitation is there might be a way to do it in the program, I don't know it yet, so just cycling it works for me. So I'm going to cycle this one, and we've got a message here on the exit, message on the exit with an LED, a red LED, trying to stop other people following up close behind the vehicle and trying to go through the barrier, because the barrier will close when that beam's broken again. So the vehicle continues out and finally breaks the beam as it clears the beam as it exits the car park. And I'll simulate that by cycling it. So just cycle it again. As you can see, the barrier starts to come down. None of the messages are changing. As the vehicle has exited the car park, we started off with 4 spaces, I think you'll remember. We're now going to have 5 available spaces. So we'll check that. So as it goes down, keeps coming, it's going to make this limit switch. Lovely. 5 car park spaces remaining. There we go. And there is nothing on the exit screen. Why would there be? So what we'll do now, we'll do the entrance of a vehicle and take that back to 4 by filling that extra gap up. But at the same time, we'll have a go at this this emergency stop switch I've put in there as well. So let's break the entrance beam. Welcome. Vehicle entering has priority. Please leave room. And a red light to reinforce it. We'll chuck the correct access code in. The barrier will start to open. Only proceed when the green light's on there, as we said before. And we're going to punch this now. And you can see the emergency stop's been pressed. Both screens know this. These buttons are linked. And when everyone's happy that the vehicle will proceed, like an emergency push button you get on the industrial machinery. Usually they lock in place. It's like a latching button, so you have to unlock it again. So we'll try that. And you see it carries on up. The messages have cleared, but when it gets to the top and makes that, we'll pick up where we left off. So this more than fits the brief I was given. I've not really used Flowcode other than a couple of lessons before, so I'm sure that people out there can probably pick holes in it and tell me I could do better, and please do. You know, I'd like to get better at this. But as far as fulfilling the brief for the module for this university assignment for my second year, I'm pretty chuffed with that. I say we do 6 modules a year, and this is one part of one module. So time is a bit limited on what I can throw at it, but still got time to do a YouTube video, eh? So that should make that switch, and we go back to 4 spaces remaining. There we go. Thank you very much.